Welcome everybody, and this is going to be the last session of the day, and I hope everybody is ready. And well, ladies and gentlemen, let's begin the last session of the day. We're going to have a discussion on construction process of metro and rail, and I take the opportunity to welcome Mr. Parveen Sharma, CEO, the BIM Engineers. Welcome, sir.
Thank you so much.
And now I allow you to start the session. Over to you, sir.
Okay, thank you. Let me share my screen. Let me know when you are able to see the screen.
Yeah, sure. I can see the screen, sir.
Perfectly fine. Thank you so much.
All the best.
What we will do in today's session, we are going to discuss how BIM, the new technology, is revolutionizing the design and construction industry. Just to set the background and the tone of this PowerPoint, I want to share some figures to emphasize the fact that how important this technology is and how we can consider it one of the biggest revolution in 21st century. If you see total global construction industry is annual currently around $18 trillion, and only Indian construction industry is third largest construction industry in the world, that is 563 billion. So lots of scope of improvement in these areas, especially when we are talking about metro and rail sector, because this session I'll focus mainly for the rail and metro sector. There are around 200 metro system in more than 75 countries all across, running with around 180 million passengers per day. I think one of the largest network of users that spread across so many countries. Total 15,000 plus kilometers metros are operating with 43 billion passengers every year. Big network, big possibility, big money involved, big convenience for the passenger involved. If you see how technology can change the life of the users, operators, managers, even the construction company, design consultant, owners, manufacturers, everyone. So I am going to discuss about one such technology which is bringing a paradigm shift in the revolutionizing the complete industry of rail and metro sector. From day one till the last date of the metro operation, even if you have to dismantle and extend, renovate, refurbish for future uses, BIM technology can bring lots of benefit in different stages. There are global case study. I'll show you some of the interesting case studies in the field, which says that around 20% of the saving of the total money involved or the total investment can be saved by using virtual construction or building information modeling technology. And time, of course, is money, but I'm talking about only the money part. Time can also be considerably saved. Around 25% time can be reduced by better coordination, better planning, and better execution of rail and metro projects using BIM. Against the saving, in comparison, the cost versus saving, the cost of BIM will be very, very less, almost 28th part of the savings it brings. And automation and technology can be very important and vital role. So to start with, I'll give a couple of slides about BIM, and then I'll cover some part about how we are utilizing these technologies for the betterment of the design and construction in our rail and metro sector. Then towards the end of this PowerPoint, I will show you some of the case studies to prove my point. To begin with, the textbook definition of building information modeling is like doing the same construction twice. So we are like, you can say in nutshell, we are virtual contractors. So we make the building twice. First, in computer, the virtual construction phase, and second, somebody who's known as general contractor or construction companies, they replicate the same construction on ground. So while doing the virtual construction, we do learn lots of area of improvement in terms of quantities, cost, design enhancement, construction challenges, coordination issues, missing information in the drawings, clashing information between two set of drawings, or contradictory information, challenges about accuracy of the drawings, accuracy of the quantity, as-built update, running, facility management, operation, finding the fault, and rectification of those problems during the operation maintenance phases of a design and construction project for rail and metro. So BIM is useful in all these stages. So in nutshell, I can say in one line, we are creating digital twin. So whatever you have on ground, we can create the digital twin in computer environment, which can exactly replicate the site installation, or you can say construction. So in nutshell, we are digital contractors. Significance or importance of BIM from the initial stage of the design till the tender, then the construction, supervision, project management, as-built update, even during the facility management, running operation, expansion, renovation projects. It can play a vital role. What is the extent of BIM? Starting with basic 3D. So currently many of the projects are utilizing two-dimensional line-based technology. BIM starts with 3D. So 3D is the base of BIM utilization, where we have everything in three-dimensional. X, Y, and G is the height or elevation. If we link the project construction schedule, which generally we design in Primavera or Microsoft project, or even in Excel sheet and Gantt charts, if we link those Gantt charts with the 3D model, because in Gantt charts you have all the activities, start date, end date, and duration. Similarly, in a 3D environment, you can get all the column, beam, duct, and all the floor plate and staircase, escalator, elevator, all elements. So if you link the project construction schedule with the 3D BIM model, it goes up to fourth dimension. So 3D plus time is fourth. Fifth is the money or cost involved. If you want to know how the construction is going to happen in over a period of time, let's say 1 month, 2 months, 3, 4, 6 months, 1 year, 18 months, 24 months, you can see that graphically in the form of 5D. And in addition to the graphical representation, you can also get to know how much cost, material, money, storage facility, or labor you will require in next 3 months, 6 months, 12 months, 15, 18 months, 2 years time. So 3D plus time plus cost is 5D. I'll give you a brief introduction to 6, 7, 8, 9 dimensions also. 60 is all about green building, sustainability, all the calculations about structural load or heating cooling load, wind tunnel analysis, and all sort of other analysis and simulations using the basic BIM 3D. So 3, 4, 5, 6, and then 7 dimension is all about the life cycle. The project is going to be, the facility is going to be in operation for next 50, 75, 100 years. So during those life cycle, how you are going to manage the assets, how you are going to run and operate and renovate and expand those facilities. So first, getting the information built into the model about the facility management and as-built condition, and then running operation and maintenance. That is 7th dimension. In 8D, what we do lots of analysis further after 25 years, 50 years, 70 years, how the building will react. When you need some sort of renovation, how it will react in case of let's say a stampede or terrorist attack or a natural calamity like earthquake or fire or flood. All those analysis and preemptive measurements can be taken using the technology now. So we go up to 8 and 9 dimension, which is very important, about lean, clean, and environment friendly construction, which is good for our future generations. The problem we face as a construction and design industry is lots of projects get delayed. I think almost all major projects are running behind the schedule. Why it happens? We can discuss it different day. Any other day, there are lots of challenges about design, coordination, labor shortage, material shortage, money shortage, but there are technical problems about the incompleteness or missing information in the drawings, clashing areas, drawings are not accurate, the quantities are not accurate, the cost estimate were not planned correctly. So these type of mistakes, technical mistakes, can be very well in advance tackled using BIM technology. And it can bring lots of reduction in terms of rework. We do lots of rework, and we do, I would say, reactive maintenance. When we find a problem, then only we find a solution. We never act to find the problem in advance. There are possibilities of this problem may come in next 2, 3 months, 6 months, 12 years, 4 years, 50 years in these areas. So we don't do preventive measurement, we do reactive measurements. So with BIM technology, we can predict and find lots of solutions to the problem which may happen during the future course of time. Especially for the owners, operators, and the government authorities for rail and metro sector, these are the main benefit. This technology, BIM or virtual construction, can bring on table. I'll show you with some case study that this technology has saved almost 2/3 of the problem areas identified in the drawings. So during the virtual construction phase, we can find lots of, for example, drafting mistakes or grammatical spelling mistakes, missing information in the drawings, some dimensions are written wrong, some sizes are written wrongly, or two set of drawings are talking about two different sizes. So all those document related errors and omissions can be rectified by the software itself. The technology can take care about the grammatical spelling typing mistake. We don't have to spend time in checking those mistakes. That is the primary benefit. Then rework can be reduced. We do lots of changes on site. That can significantly be reduced by doing the same construction twice, virtually and physically. Construction cost, time duration, and litigation and claim can also be significantly reduced. These are global case studies to prove these claims, to substance these numbers. And then I can further explain more about some proven case studies and benefit from Australia to US to Europe. There are lots of interesting case study where people say whatever you spend on investing, invest into implementing these new technology like BIM, the return of investment can be even 500%, 300% in some of the cases. How these technologies are changing the way we work, especially in rail sector, coordination and efficiency. By using three-dimensional BIM technology, we are bringing all the stakeholders from architect, civil engineer, structural consultant, electromechanical plumbing consultant, overhead cable, tracking system, rolling stock, fare collections, all sort of consultant and contractor onto one single platform. That is BIM. And if all the stakeholder talks one language, they use the same platform, pre-design as well as during the construction, it will bring lots of efficiency. The question asked between different design consultant can be eliminated by 2/3. Stoppage of construction process because of the lack of some information. Sometimes you have to delay the construction or change the schedule, do lots of rework. Sometimes we do some small demolition or design changes on site. Those can be predicted well in advance during the virtual construction phase, sitting on a chair rather than going on construction site and taking decisions there in a haste. Value engineering is another proposition which brings this technology brings on table. Reduce material labor cost, improved efficiency in the system. You can make system more intelligent because you can virtually walk inside the building in BIM environment. You don't have to physically install and then find the mistake. In virtual construction, you can see the facility, you can see how it works, you can do some design changes, and you can do two different combination between different design options. In BIM, it's quite easy and it saves lots of time and money and bring value engineering and make your system more intelligent and efficient. Project management, very important aspect. It allows client to get complete control over the construction process. So through 4, 5, 6 dimensions, you can get better control over collaboration, coordination, risk mitigation, logistic planning, even the cost estimate, warehousing, and even bill settlement. These processes can definitely have lots of scope for improvement, and BIM caters to that requirements. Change management, because change is permanent. In construction industry, it's constantly keep changing, revolutionizing or evolutionizing themselves based on our past learning or recent learning. So BIM take care of the change management very efficiently, and it brings a new paradigm in this direction. This technology BIM has been a big revolution, or I will say complete change for rail and metro sector. In all aspects, it has bring lots of efficiency and solutions to the traditional problems, whether it's civil, site design, or electromechanical, or heating, ventilation, or air conditioning, plumbing systems, electrical designs. Plumbing system can be improved. You have better control over quantities and cost estimates now, and these are pretty much accurate. Coordinating with the local guidelines, better space utilization through BIM. You have these metro and rail project in very congested area where you have very limited space to develop these facilities. Especially using BIM, the space planning can be better. Orientation of equipment and panels can be more user friendly and money and time saving. Facility management integration during the operation and maintenance, it brings lots of value. Prefabrication is getting very popular because of the congested site spaces. Most of the construction happens off site, means in the factory or yards. You do the construction, you cast the structural element, bring them on site, do the assembling, and BIM facilitate those processes because there you require pinpoint accuracies. 100% accuracy is required, and BIM brings those efficiency. Value engineering, you can do the improvement in the system, defines constructability, material labor cost, site space planning, warehousing, bill settlement, as-built update through laser scans. These are all small benefit coming using BIM. Lots of processes I want to share. How BIM implements on site, from receiving the client input, start doing the data analysis, doing the 3D modeling. Along with the client, we sit and we discuss how BIM can change the way client has been doing the traditional design and construction processes. During the design development, we do lots of coordination between different disciplines, identify the problem area, do some value engineering, extract accurate set of drawings, get very precise quantity out of it, do some drawing production, sheet extraction, internal QC, external QC, markup, revision, coordination, and then doing the final submissions. Now, couple of things about our organization, which I represent. We are one of the global leader in implementing this technology called BIM. The company name is the BIM Engineers. We are headquarters in Netherlands and with Global Design Center in Gurgaon, India. We have around 500 engineers working all across the globe in more than 70 countries. So we are present in 25 plus countries with our team, and remaining 70 countries we are catering through our Global Design Center and the head office in Netherlands and India. Lots of interesting projects. That's our global footprint. If you see the blue color are our head office and Global Design Center, but all across the world in Denmark, Middle East, South Africa, Germany, Sweden, UK, USA, Panama, South Africa, Australia, these are our branch offices for the BIM engineers. This is the European head office building in Netherlands, and this is our Global Design Center in Gurgaon near New Delhi in India. We have been recognized on many global platforms, seminars, exhibitions, universities. So we do active participation in lots of international events, and we have been recognized. These are some of our contribution and recognition from various stages and organizations. Some of the events where we have presented our capabilities, including UK, to Australia, Singapore, Thailand, Middle East, Spain, UK, Germany, Netherlands, India, Las Vegas in US. I can show you some of the case study where we have implemented BIM, starting with the Mumbai Metro line, phase 2 and 3, NCRTC between Delhi Meerut, Singapore Metro. We have implemented BIM on Singapore Metro project, multiple stations. This is one of them, is a depot project. Another Delhi Meerut high speed rail. Pune Metro, we have implemented BIM. Malaysia, we implemented BIM for level of detailing, which is advanced level of BIM for this 52-kilometer long metro line with 35 stations. Some of them were elevated, some of them were at grade even, and some of them were underground. More detail about the Malaysian metro. Chennai Metro, we are currently implementing phase 2 BIM on this project. West Kowloon in Hong Kong, connecting China to the Hong Kong island. So we do lots of high-speed rail and metro station in Hong Kong, West Kowloon. SNCF is the French rail which manages all the metro and rail projects. So we have done around 65 kilometer for almost 1 year. We are working with SNCF in France. Eurostar is one of the oldest metro facility in the world. Between different countries in Europe, they have this Eurostar trains. So we do lots of integration between laser scanning, converting them into edge build, and planning for future maintenance and expansion and renovation for these Eurostar facilities, check-in stations. Deutsche Bahn, where we have implemented BIM for the German rail, lots of station, lots of line. Eurostar, again, high-speed rail in UK between London to Temple. Delhi Metro is another big user. In India, now BIM is getting very popular and lots of credit goes to Delhi Metro. Delhi Metro have been using BIM for all their new projects, new lines, even into their consultancy business for other projects. DMRC is one of the biggest user of BIM in India. So we have supported multiple phases in phase 3 and phase 4 and multiple stations for implementing BIM in Delhi Metro. What value we bring as an organization is we identify the problem area, do clash detection, coordination between all the services, do the standardization, naming convention, whether it's folder structure, identifying the problem areas, or construction drawings, classes, coordination, individual service drawing, combined services drawings, quantities extraction, and even doing the edge build for these projects. Patna Metro is another such project where we implemented BIM recently. Mumbai Ahmedabad high speed. This is going to be the first bullet train in India. So we are working on this project for implementing BIM. Quite challenging, first project of its kind in India. Very challenging. Along with rail and metro, we also implement BIM for other infrastructure projects in airport, highways, tunnel, bridges, oil and gas plant, building. So this presentation was more focusing towards rail and metro, but very briefly and within few seconds, I can run you through our portfolio for other projects, including Heathrow Airport, Delhi Airport, Navi Mumbai Airport, Chennai Airport, Singapore Changi Terminal 4, Schiphol Airport, Hong Kong Airport. So we have done lots of airport project where we implemented BIM. Then coming to building sector, lots of residential development, hospital in Denmark, another hospital in Sweden, nuclear power plant in Finland, lots of furniture stores, superstores, Tesco stores, Starbucks coffee shops, commercial building, Tesla Gigafactory for electrical vehicle, lots of data center in Colombo, Dublin, Ireland, police headquarter building in Ireland, Airtel data center in India, Folkestone mixed development, apartment buildings, defense project, laboratories, high-rise, mid-rise, hotels, football stadiums, Mall of Netherlands, defense projects, laboratory buildings.
Through BIM.
So this is a long list. I don't want to spend lots of time. With this, I'll conclude my presentation. And if you have any questions,
through BIM,
we can discuss it now, or otherwise we can conclude this presentation. I'll wait for your questions. You can ask in the chat box, or if you want to talk verbally, you can ask your questions now. I think I finished right on time. So next 5-7 minutes we can keep for question and answer, and then we can conclude this session. Anybody want to ask anything, please? You can note down my contact details, my email IDs, multiple addresses. You can find me on social media like LinkedIn in the name of Parveen Sharma, and the organization name will be the BIM Engineers. You can go through our website, which is thebimengineers.com. Want to know more about the portfolio services, any business opportunity? We'll be happy to talk to you anytime. You can find my contact details in social media on our website. It will be a pleasure to meet you anytime, face to face or virtually, and we welcome all of you for any sort of business discussions. And we can take this discussion forward offline in one-to-one. If you want to ask any business related discussion or question, we can do that. If you want to ask any general question about the technology or our company, you can do it now here in the chat box or through even microphone you want to ask.
Thank you, sir. It was really wonderful. And whichever question comes to us, we are going to forward to you on your email. So
Perfectly fine.
You reply, yeah. Thank you. So, thank you.
And thanks to the organization for arranging this wonderful session. Very helpful. Thank you so much.
Thank you. So now we come to an end, and before we close the day, I would like to thank all the panelists, all the speakers, and the sponsors for being so participative. We had a wonderful day and a wonderful time. Throughout the day, it was really, really informative, and I hope we take a lot of inputs from this session. And now we begin the. What is that? Yeah. Well, thank you so much. We continue with the networking still. And once again, thank you all the sponsors for being a part of this. Thank you so much and have a great evening. Have a great time. Thank you.